What you're seeing here is my 3D brain. Well, not my brain, my second brain. This is the AI. This is everything that my LLM Wiki knows about me, about my mission control dashboard, which I'll show you in a second, and everything there is to know about my AI agents, as well as any VPS architecture, because I'm currently hosting this VPS on Hostinger. So very, very cool. I basically took Andrej Karpathy's LLM Wiki and looked at some of the guides online that people were using for an obsidian graph and took it a step further because heck, why not, right? So let me show you what's going on here. This wiki is still relatively small. It's still in its infancy at the moment, but there's basically some information in here. And if I just query this specific graph and say, what skills does heavy arms have? And hit enter, you can see immediately there's a pulse of there's a pulse of light that goes out to several different nodes. And it's just a case of waiting now. So basically, if I wait in the background, I'll explain what's going on. I have Claude code running in the background on my VPS in a Tmux session. So it stays persistent. If I ever log in via SSH, it's actually running as a different user. And Claude code is always running. I interact with it via Telegram if I need to. My primary agent is an agent called Wing0, which is this guy. Look at that. There's information coming back from the relevant sources. And it's telling me in its response that Heavy Arms has these skills: feature dev, code review, code simplifying, commit commands, PR review toolkit, etc., etc., etc. And if I go over to my agents, you will see, indeed, that is the skills that Heavy Arms has. I've got a bunch of other agents here as well, but that's a topic for a different day. So, building a 3D second brain, how I turned Obsidian Vaults into a living neural network. So this is basically, like I said, building on Andrej Karpathy's existing LLM Wiki gist, which is hosted on GitHub. I'll put all the links to the description. I'll put all the links in the description of this video, so credit given where credit's due. Follow Andrej Karpathy. I'm sure some of you guys know who he is already if you're in the AI space. If you don't, you're probably living under a rock, and you should follow him because he's one of the goats in the AI space. So essentially, this is basically written like an ordinary human, right? It's basically Andrej expressing his concerns about having to maintain copious amounts of information and what the roadblocks are when it comes to maintaining that and how LLMs can help. So all you need to do is point your LLM to this specific gist, and your LLM is immediately going to know how to build this out, right? So if I go back to our little slide deck here, so these are some of the notes from that gist as well as quotes. So notes are scattered across tools, apps, and folders, which is so true because many times you may have tried to create structured a folder system with subfolders. Maybe you've given your folders certain names or prefixes, a naming convention. Maybe you're giving folders specific icon colors. At the end of the day, it just still becomes too much, right? Connections between IDEs exist, but you can't see them. So the nice thing about having an Obsidian Vault is everything's linked by quote unquote a wiki link, right? Which references one MD file to another. Maintaining a knowledge base is tedious bookkeeping, which it really is. And to quote Andrej Karpathy, the tedious part of maintaining a knowledge base is not the reading or the thinking, it's the bookkeeping, which is so true. Obsidian 101. So Obsidian is a note-taking app, specifically works with MD files in a local folder or a vault, quote unquote. It connects notes with wiki links, as I mentioned earlier, and it creates a knowledge graph, and its knowledge graph is rendered natively inside the application itself, but it's flat and it's 2D. So this is why I wanted to expand on it and also have that animation to show almost like a digital representation of synapses firing off. So you can see this is a representation of what a Obsidian graph looks like. The LLM Wiki pattern, as explained by Andrej Karpathy. So at the very top, you have your raw sources. So you would have things like your blog posts, articles online, papers, pictures that you may have scanned. You may have journals. You may even have YouTube transcripts that you're feeding into AI, right? So that's your raw data. You're going off and getting a transcript, and you're storing that and you're feeding it into AI. Then this is where LLM comes in, right? Because LLM will actually generate the pages, the entities, the concepts, the comparisons, and all of that will be relational, a bit like a relational database where you get to see the schema and how your primary key relates to a certain foreign key, and your foreign key relates to different keys, and then you got relational tables, so on and so forth. Very, very similar concepts here, except for you're just seeing it in a node graph, which is very, very cool. And then you have the schema. So your rules, conventions, structure, and the grammar of your wiki. You can imagine having a wiki of 1,000 pages and then having to remember that every time you create a page manually, you're going to have your H1 tag at the beginning, your H2 subtitle, and then your wiki link, which references another document in another folder somewhere else. It's going to be like the third item on the list. And trying to remember that and having consistency across every single document manually is going to be an absolute mammoth task. And I would say almost impossible, to build that relational information together is just going to be an absolute ball ache to do manually. So how I built it, I used the Obsidian Vault, like I mentioned. I'm using a React application, which is my mission control dashboard. Again, a topic for another day, but if you want me to run you through my mission control dashboard, what it does exactly, comment mission control down below, and I will make a video explaining every single thing that's going on here and how my agents actually have a DevOps pipeline where they build me applications just so I can test them out, right? Concepts, ideas I might have. I'll put them into the backlog, run the pipeline, and then you'll see the task transition from one stage to another. But before I lose my train of thought, going back to the slide deck here. So I have an Express APIs. This is basically for the graph, the 3D graph. 3.js is the JavaScript library that's being used to render that graph. Now, I was initially using Claude, but I ditched it, and I'll explain why. There's also WebSocket, which is the middle layer. This is the real-time pulse events broadcast to browser. So any client events that need to happen in the browser on the read or write of these empty files needs to be, the client needs to know when to render this, right? Because this is all happening locally with JavaScript. So there has to be a WebSocket that's opened up in the background to listen to these events. And this is exactly what's happening. Going back to what I was saying earlier about Claude. So in fact, let's just talk about this. So the living brain. So this is basically a force-directed 3D layout. Nodes repel and linked nodes attract. There is also Bloom post-processing. Everything close. Let me explain what that is. So if I go back to the Nexus graph, or I call it a Nexus graph because this is the name that Claude Code came up with. But if I zoom in, you will see that this starts to bloom, which is quite nice. And there is actually depth to this Z-axis as well. So if I was to zoom out, you can see the nodes are fading away. You can see the whole thing fades away there. And as I zoom in, comes into view again. And as I rotate around and orbit around this, you can see the nodes that go further into the distance on the Z-axis actually fade away, which is a nice touch. Really, really cool. Let's come back to our wiki here. So CSS labels I've kept as well. There's also some motion blur as well, just to make sure it looks a bit tidy. But the CSS labels is key for me because I wanted to see the CSS labels as I maneuvered around this graph. So as I move around the nodes, I can see, for example, that wing 0 is there. It stays intact. It's anchored to its relevant node, which is very, very cool. Coming back to our slide deck, nearly finished here. We've got the Starfield background plus a floor grid. This is almost non-visible. You won't see it on video most likely, but it's there. It's very faint, but it's there. So watching your brain think is very, very cool. What's happening in the background? We have something called fs.watch, which is basically designed to detect file changes inside the vault. Anytime AI reads a file, anytime AI writes a file, we get that pulse animation show along the node line that connects one node to another, right? Which is really cool. The WebSocket broadcasts the events to the browser, like I mentioned earlier. The pulse dots travel along the graph edges in real time. And there's an 11 dot trail with envelope fading. So for those of you guys who are like into video editing or audio design, you'll know that envelope fading means applying a fade in and fade out transition in a certain fashion. And so what I wanted was to have a pulse of light sort of fade in and fade out, trying to have a digital representation of synapses firing off, because it didn't really make sense to have a bright spot that would just spontaneously appear and then disappear. It just wouldn't look very good at all. So there's that. And it's basically your turn. There's a prompt that I've linked in the description of the video. Use the prompt. Use any capable LLM. I would say one that's got some good reasoning. So GPT 5.5, of course. And then obviously you've got Claude Opus 4.7. And you'll need an Obsidian Vault as well. And at this point, I will be cheeky. All the resources are in the description of this video, by the way. And I'll be cheeky and ask for a sub if you like this kind of content. So don't forget to drop a like and maybe subscribe to the channel, because it would really help the channel grow. So going back to what I was saying earlier about Claude, I actually used Codex, so GPT 5.5, to build this graph. And the reason I did this is because even though Claude Opus 4.7 is a very capable model, when it comes to 3D design of applications or JavaScript-based games with 3.js, GPT 5.5 does a much better job when it comes to object detection, collision, particle effects, all that sort of stuff. It just seems a lot more refined. When Opus actually implemented this initially on my mission control dashboard, it was clunky. The orbit controls didn't work properly. I prompted it numerous times to the point where I just almost gave up, and I was being extremely specific with my prompts as well. Did the same thing with Codex. I needed to refine it a bit, but I got there in the end, and it just with a much fewer prompts, by the way, and it looks so much better as well. So I then generated a static HTML file. You can see here, index.html, fed this into Claude, and I basically got my AI agent to implement that in my mission control dashboard. And like I said earlier in the video, if I didn't mention already, my primary method of communication between myself and my agents Well, this guy here, Wing Zero, is through Telegram. So if you want to see me explain my mission control dashboard in detail, show you how everything works, just drop a comment in the video below, and I'll see you in the next one. Cheers.